Nearly every single item produced in the world today relies on electrical engineering in some part of its manufacturing process. From the most technically complex items, like smartphones and smartwatches, to the simplest items like pencils and apples. Without electrical engineering, the production of these items would not be nearly as efficient nor as cheap as it is today. Although there may not be any electrical components in an apple, without the irrigation system to water the trees, or the trucks to transport them from farm to store, apples would be much harder to produce and would be much more expensive. Without electrical engineers, the world would not be nearly as efficient as it is today. Electrical engineers help make life easier and they make life better. So, if electrical engineers are so important, what exactly do they do? Electrical engineers are in charge of the designing, development, testing, and management of the manufacturing of new electrical equipment with the goal of making things more efficient or easier.
Several subdisciplines of electrical engineering. Some of these include electronics and communications engineering and computer engineering. We also have subdisciplines like data engineering, which is responsible for designing and creating pipelines that transform and transport big data into a format that is in its usable state. Data engineers prepare data for analytical or operational uses. We also have telecommunications, software engineering, and hardware engineering. Telecommunications design voice, video, and data communication systems in order to keep users connected. They install equipment incorporating cabling, complex networks, and switching systems to transmit phone, cable, and broadband data. Software engineering is the application of engineering principles to software development. Software engineers analyze user needs to design, develop, and test end-user applications to satisfy their needs. Job opportunities for software engineers include becoming a full-stack developer, a data scientist, software architect, and application security engineer. Hardware engineering involves the process of designing, developing, testing, and producing computer systems, including various physical components related to computer systems. Hardware engineering branches off into financial services, public services, consumer services, manufacturing, as well as technology.
There are many different paths that can be taken to become an electrical engineer, but when pursuing a career in electrical engineering, these are the 4 most common steps. The first and most common step taken is to get a bachelor's degree in engineering. After getting a bachelor's degree, you can then get a master's degree, which often determines one's specialization or pushes someone towards the management side of engineering. After getting a degree, there are many different kinds of certificates that you can get that help create standout applications and prove specializations in certain areas of engineering. The fourth and most prestigious step that you can take to becoming an electrical engineer is to get an engineering license. Only about 20% of engineers have their engineering license, which is what makes it such a prestigious award. There are many different certifications you can get as an electrical engineer. Some are more broad, like Project Management Professional, which proves ability to manage projects, and some are more specific, like Certified Energy Manager and Supervisory Control and Data Acquisitions, which are extremely helpful when pursuing a career in electrical engineering. Although electrical engineering may seem like one of the more complex subdisciplines of engineering, the skills needed to be a good engineer are pretty universal among all subdisciplines. You must be organized, have good critical thinking skills, and have good interpersonal communication skills in order to work efficiently and effectively in a team. You must also have extremely good mathematic understanding of physics, and understanding of technical components due to the extreme complexity of the tools and components that you'll be working with as an electrical engineer.
There are several different disciplines needed for these projects. First, we have our electrical engineers, which are responsible for developing, designing, and testing all the components for these projects. Then we have our computer scientists, which they use data science, robotics, and computer systems to improve or create algorithms or softwares. Also, we have our computer engineers, which they're responsible for actually building the computers, such as PCs, workstations, and even supercomputers. Top 5 universities for electrical engineering. At first spot, we have MIT. MIT has an artificial intelligence-based teaching, which means that they use artificial intelligence for their students to study and research different projects. At second spot, we have Stanford. Stanford has a practice and career-based teaching. Then we have Harvard. Harvard has a project development style of teaching, which means that their students work together with professors to develop different projects. Right now they're developing quantum devices, millimeter scale robots, and they're trying to optimize the power grid in California. At 4th and 5th spot, we have Yale, and we also have Princeton. Research experience for undergraduates. We have Arizona State University, the University of Arizona, and University of California are a couple of the universities we researched. Also, we have a couple of internships, which we'll talk about later. The University of California and Arizona State University have a similar application process, which is one simple application, and you will get assigned to a research experience that they see fit and one that's available. They have compensations anywhere from $3,000 to $10,000. Then we have the University of Arizona, which they have a more open program. You get to choose if you want to have a research experience that was created by you. You get to choose a professor, which if you want to work with one, and you also have the opportunity to start your own business with their entrepreneurship program. Then we have our internships. There's 5 internships open at the moment for Intel. They are all temporary, they do not specify the compensation, and they're all for the upcoming summer. We also have Microchip Technology, which they have a full-time internship open right now. Their compensation and all the details are available on their website.
Engineering societies are essential to the progression of different parts of the engineering field. Each society has its own goals and focuses. Societies such as the Institution of Electrical and Electronics Engineers and the Society of Telecommunications Engineers focuses on the engineers themselves and developing their careers, whereas societies like the Audio Engineering Society focuses on the field itself and developing its products.
Good afternoon, my name is Joel Fonseca. I had the pleasure of interviewing Ken Klaus. Ken is an electrical engineer that works at General Dynamics. His subdiscipline is hardware engineering. So on this slide, I have a few of the questions that I had asked him throughout the interview. First, what made you interested in engineering? Ken had mentioned that as a child, he loved to take apart things, try to figure out how they worked, and try to put them back together. This seems to be a very common trait. Ken said that it's about inspiring curiosity. Next, we have, what types of projects do you work on? Ken said that he works with government contracts for secure ground-to-space communications. What this means is that he works with cryptographic systems for satellite communications. Next, we have, what was the most rewarding part of your career? Ken had mentioned that he has multiple awards, multiple patents, but above all of that, what really keeps him engaged in this career is that he loves to see a project from start to finish to production, and he loves to see that project succeed. It is a personal investment of his. So, the next question is, what was the most challenging? He said that telling upper management that he wanted to stay on the technical side of projects. He did not want to become a project manager. He wanted to make sure that whatever work that he was putting his name on was going to be successful because he was doing it, and he was doing the innovations for that. So on this slide, we have a few examples of some electrical engineering projects that we may work on in the future. First up, we have telecommunications. We have radios and satellite communication systems, similar to what Ken works on. So I have a few pictures of examples. We have a radio, we have a VSAT system. Next, we have consumer electronics, which are smartphones, laptops, gaming consoles, all things of that nature. Lastly, we have hardware, and this is what specifically Ken works on, which are circuit boards, microprocessors, data storage devices. So a goal of electrical engineering is continuous innovation, whether it is making things smaller, making processors faster, increasing resolution, and above all, making them more cost efficient.